welcome
Hello.
back to my channel.
Say it louder, Carl.
Welcome back to my channel.
Bing! So today we are continuing on with the same, what would we call it, procedure for factoring and simplifying that we learned last time, but we're going to use it slightly differently. Are you ready? It'll be very helpful if you were in Desmos, okay?
Got it.
Okay, so fractions have a very interesting property that hopefully you guys are familiar with. So somebody plug into any calculator that you have. What's 0 divided by 1? Really do it. Really check it. What is it? Somebody tell me.
0 divided by 1 is 0.
Okay, Carly did it on her phone. Gave her 0. Okay, now do 1 divided by 0.
Error.
Her phone says error. And the reason why is because you cannot divide a fraction by 0. It's not possible. This is what we call undefined. It's like a mathematician's way of saying, we don't know. We're not sure. It's fancy for, I don't know. Because this property exists, that makes things a little bit complicated when we're talking about rational expressions, because rational expressions are fractions, and we have to be really careful that we don't have a 0 in the bottom of our fraction. So to remember this, there's kind of an interesting little trick. So 0 divided by 1 is OK. You make that 1 in the bottom a K. This is like a little trick to remember which one's allowed. 1 divided by 0 is no. You make the 1 an N. So if you ever forget, you can have a 0 in the top. That's okay. You cannot have a 0 in the bottom. That's a no. That's pretty cool, I think. So we are going to find today the excluded values for rational expressions. Excluded values are values that will make the denominator of your fraction equal to 0. So we can't have any x values that are going to make your denominator 0. When it says values, we should probably note that they're referring to x values. So I'm going to write that down. Our values, these are x values. Some of your trinomials last time, I think, had like letters like P or N or K. That's the same thing. So when we say x values, we mean whatever letter the variable is. So you cannot, the next blanks are, you cannot divide by 0. So it's very important to find these excluded values when simplifying rational expressions. And simplifying is what we did last time. So this is a 2-step process. The first part is you need to factor the denominator. And family, you must make sure you do the denominator first, which seems weird because for me, I feel like I would want to factor the top then the bottom. But it's very important that you start at the bottom because your excluded values are in the bottom of the fraction. Then the next thing says, set each factor equal to 0 and solve the equation. That's going to be easy. We're actually not going to need to do that. Most of you guys will be able to just do it in your head. Okay, so let's skip the pictures for now. Or sorry, yeah, skip these pictures in the bubble. And let's go down to our first problem, number 1. So essentially the question they're asking is, what values of x will make our denominator 0? So how you decide that is you say, okay, our denominator is x plus 7. What will make that 0? Well, you guys know if you have an x plus 7, what is x then? If you have a plus 7, x will be what? Minus 7. That's how you always solve the equations. So your excluded value here is x is negative 7. You cannot plug a negative 7 into that denominator. Are you okay so far? So essentially, it is the opposite of what you see in the bottom. If you have an x plus 7 in the bottom, that means your excluded value is a negative 7. Let's just skip 2. I don't want to do 2. And flip to the next page. Okay, so now this time we have 2 factors in the bottom. 2 factors in the bottom means we're going to have 2 excluded values. So we ask ourselves, what will make a plus 4 equal to 0? And what will make a minus 3 equal to 0? Well, based on what we just said, it's the opposite of what we see. So a plus 4 would be an excluded value of negative 4. And a minus 3 would be an excluded value of 3. So it's the opposite of what you see. And that should make sense because when you add 2 opposites, they're supposed to equal 0. A negative 4 combined with a positive 4 is 0. And a positive 3 combined with a negative 3 is 0. So if you want to figure out what will make that factor 0, you just find the opposite of what is there. Because when you combine it, they'll cancel out. Is that making a little bit of sense? You're sure? Okay, so next one should be pretty straightforward, right? 2 factors in the bottom. So that means we're going to have 2 excluded values. What are our excluded values this time? Minus 5 and a positive 3. Cheyenne knows that because she's going to do the opposite of what she sees in the bottom. So opposite of plus 5 is going to be negative 5. Opposite of negative 3 is going to be positive 3. So everything's fine, we're cruising, and then we hit number 5. So what's different about number 5? Well, it's in standard form. So what we need to do is change this so that it's in factored form instead. And this is what you guys did last time. You had to use Desmos to figure out what p squared minus 4p minus 12 factors to. So remember, what we did was we would go into Desmos. Now for Desmos, you have to plug in an x, not a p. You guys know that, yes? Do you?
Yeah.
So if I go to my graphing calculator in Desmos, I have to plug in x squared minus 4x minus 12, and my x-intercepts will help me factor this. So my first factor is going to be p plus 2. My second factor is going to be p minus 6. That's based on what we did last time. You're hanging in there? Okay, so now when we write our excluded values, we got to do opposite of what we see. So our excluded values are -2 and +6. So far, so good?
Yeah.
Are you sure?
Yeah.
Okay. So, do I want to do this this number 6? Yeah, I don't think I really... Let's change the denominator. Let's do x squared plus 7x plus 12 in the denominator instead. And we don't even need to worry about the numerator at this point, because remember, our first step is always look at the denominator. So you can plug that into Desmos. I'll help you a little bit and tell you that they're both going to be a plus. Appreciate those of you that are actually typing in right now. About 20. $10. 5. 3, 2. Okay, so our factor should be what? X plus and X plus. Thank you, Hugo. So it's the opposite of what you see. So your factors are a +4 and a +3. To find your excluded values, you do the opposite of what we have written down here. So -4 and -3 are your excluded values. So let's try this very last one, number 7. Let's find the factors in the bottom. Once we do that, we can talk about the next step in this lesson. Give you about 30. $20. About 10. Okay, it should be X plus 1 and X plus, perfect. So excluded values are a -1 and a -6. Okay, so this is only step number 1. So in pencil, the first thing I did was I went through, I found my excluded values based off of the denominator. Well, turns out we actually have to look at also at what is in the numerator. So here's why. If the factor is only in the denominator, the excluded value is going to be an asymptote. With a P, even though you don't say the P. Tote. Asymptote. Asymptote. Nobody really says asymptote. They say asymptote. An asymptote is like a fence. It's like a fence in your graph. So down here, I have an example of two asymptotes. You have a vertical asymptote. So I'll mark that in yellow. So you have a fence here. This is a fence at x is 1. And then you also have a fence at y is 4. So an asymptote is like a line in your graph that the graph never really touches. Your graph approaches your fence but can never touch the fence. It's like a barbed wire electrocution fence. Like, what is it called when it can electrocute you? An electrical fence? That doesn't sound right. But you'll explode if you touch it. And so will the graph. So these fences, the graph cannot touch those fences. So notice that the graph avoids it. Do you see what I'm saying? So this happens if the excluded value is only in the bottom. Only in the bottom. If it's in the top and the bottom, then the excluded value will be a point of discontinuity. It will be a point of discontinuity. Say that 10 times fast. It will be a point of discontinuity. Well, that's just a fancy word for hole. It's like a hole in the graph. So in this particular graph, you have a fence and a hole. So you have a fence at x is -2. This time it's labeled for you. And a hole, a point of discontinuity at x is 2. Do you see that really teeny tiny open dot, open point? Thank you. So this is our second element. First thing we do is find the excluded value. Second thing that we do is decide, is it a fence or is it a hole? Is it an asymptote or is it a point of discontinuity? It's really easy to tell once you factor them because that's exactly what you guys did last time. So for this particular problem, x plus 7 is going to be an asymptote. You can just write the letter A if you want. So if I plug this into Desmos, I'm going to see a fence where x is -7. How do I know it's an asymptote? Because there is not an x plus 7 in the top. It's only in the bottom. So while you guys are writing that down, I'm going to go to Desmos really quick and plug in this graph. So in the bottom, in the top is 6x, in the bottom is x plus 7. And if I zoom out, you will see that there is a fence where x is -7. Can you guys see that? Yes or no? Okay, flip the page. Okay, number 3. We get lucky because it's already factored for us. The top is factored and the bottom is factored. So we check our asymptotes. We check our excluded values. Is there an a plus 4 in the top? No. So that means that -4 is an asymptote. Then we go to our next one. Is there an a minus 3 in the top? No. There's a 2a minus 3, but not an a minus 3. So this is also an asymptote. So if I graphed this guy, you're going to see a graph with two fences. It's x plus 4, x minus 3. Okay, so if I zoom in on this, can you guys see that this graph is looking really weird? So let me put the fences in. I just told you we're going to have a fence at -4 and a fence at 3. Is that what we're seeing in our graph? Are you shaking your heads yes? Yes. Okay, number 4 is another easy one because it is factored for us. So this is the first one where we have a factor in the bottom and the top. So that means that -5 is a whole or a pod, whichever one you prefer. It's either a point of discontinuity or you can refer to it as a whole. Then we check our x minus 3. There is not another one in the top, so he's an asymptote. If we graph this one, though, he looks different. So if I go up here and I say -x times x plus 5, and then in the bottom we have a +2, just kidding, a +5 and a minus what? What's the minus? Ooh. Is it 3? Okay, thank you. So let me turn off the fence. Okay, so our fence is supposed to be at 3. But if you want to find the point of discontinuity, you have to drag it to that point, and you can barely see it. So if you're sitting pretty close to that other screen, you can see that if I go click on -5, it does tell you that that's undefined or an excluded value. But if you don't go and click on it, it doesn't show you that whole. Okay, so the next problem is where it takes one more step. Is it? Nope. It's factored. Okay, so you guys decide for this one because it's all the way factored out. What are your excluded values? Are they asymptotes or wholes? Both of them? Oh, okay. There is not a p plus 2 in the top, and there is not a p minus 6 in the top. If it's only in the bottom, it's an asymptote. Okay, well, let's check our next one. And this is the one now where we have to factor the top as well. So we got to plug into Desmos, x squared plus 4x plus 3, and figure out what those factors are. I'm doing this in a separate color so that when I go to do my quiz, hopefully I'll remember that you only look at the numerator at the end. You guys finding those factors? What are they? 3 and No. You got to find the ones in the top. So you're factoring out the numerator. So if you plug that into Desmos, you should get that this factors out to x plus 1, x plus 3. Now you have x plus 3 in the top and the bottom, which means this is a whole. This is an asymptote. So if it's in the top and the bottom, it will show up as a whole in your graph. If it is just in the bottom, it ends up being a fence, because remember, x cannot be these values, or else your bottom will be 0, and that's not allowed. Okay, you got one more. So you got to factor this top guy. You got to do it in your head or plug him into Desmos and figure out what he factors to. Hugo, did you get them? What are they this time? What's your signs? Perfect. And yep. So this time, -1 is your whole, plus 6, well, x plus 6 is your asymptote. So over here, if I'm doing this on my quiz, I would say -1 is my whole, -6 is my asymptote. So the biggest takeaways before you start practicing this in your quiz is that you start at the bottom. Remember, in all of these problems, we found the excluded value first. We went in and found the denominator. Then, after you already know the excluded values, look at the numerator to see if it's a whole or an asymptote. Is that making sense?
Yes.
Are you sure?
Yes.
Denominator first, then check numerator. Okay? Okay. That's it. Get cruising on your quiz to see how you feel about it. If you